full of seats if anyone needs one, but not enough for everyone.
Is there any more people coming? Probably.
Yes.
Okay. So we have Camillo here and we have Amy, who are two of the techs that I worked with last. We also have Josh down here, and then Cam sits somewhere around in the 3D visualization kind of space around the corner. They're going to do the little safety intro and then demo some of the equipment and capabilities of the space and talk about how they can help you out with your studio projects. I'm going to leave you with Boy as well, so any questions about the studio and assessments, obviously Boy can help you out with that, and I'll be upstairs for the rest of it. All good? Enjoy, guys. Have fun.
Thanks.
I'll hand it over to you guys. Thank you. Right? I don't think we've met before. Have we? No. Camillo. Oh yeah, Camillo for everybody. I don't think I've met anyone. No? Have you been in the Makerspace before? It's the first time? Yep. I see a few heads nodding. Yeah, good. Right. Let's try it. Everybody try to spread so you can hear me well.
Come right in, it's all good. Not that scary.
Good, good. Just going to check is that we have a rule about shoes. We should have mentioned that to Kevin before. I only see one person.
There's two actually.
We're going to be extra careful. So.
Yeah.
We need to keep a stinky pair of boots for people to wear.
Yeah. I do have a sticky.
Let's live it.
Oh, yours.
Cool. Yeah, I'm gonna first start with a few things about safety. Josh, you help me out if I miss anything. Main one is gonna be, remember, if you come to the Makerspace, always to have closed shoes. That's gonna be a big important thing. If you come any other time to do any work in here, and you don't have the proper shoes, we're gonna ask you to place this outside because we have to take care of everybody that comes in here. Next after that is going to be safety glasses, which we have them always on the front area. As soon as you pass this table, you're going to have to carry those safety glasses or put on those safety glasses. If you already have some glasses, no need to worry, you keep the same ones. So lucky us. But everybody else, and when we move into the laser cutters, please grab one of those. You can clean them with the wipes that are in front, and always keep them on you. Sounds good? Perfect. Next one is going to be for anyone with long hair, which I just realized we have a lot of women in here. That's fantastic. Only one guy. Good. But yeah, we're going to ask you for you to tie your hair as much as possible. If you have long hair, anything that passes your shoulders, please tie it up. That's a good rule to keep in mind. And the way that I always tell everybody to find out if you need to tie it up, if you lean and your hair flows, that's a sign that it can get caught in the machine, so that's when it's better for you to tie it up. Cool, makes sense? Excellent, thank you. The same goes for anything that you wear, like necklaces. You just put it inside your shirt, or if you have a scarf or any jacket that is really soft or it flows in any way. That, again, if you lean and you see things flowing, that's something that you need to tie it up, make sure that it's clean. The binder is one of those. If you have a jacket of something, now we're going into summer, so it's not going to be much of a problem, but for example those are the things that hang in there, you can tie it up. Thank you, beautiful. You can do something like I did in here, is use feeder knots. The only thing is that when you lean, it doesn't go in front. Make sense so far? Cool. Josh, you want to help me with what else?
I just noticed people that have got some jackets and bags and stuff. So what we do is we just put them under the desk, any desk that you want, and that's the kind of good place to keep things out of the way and store them.
So the idea is going to be never put things on the floor.
Yep.
Because that is a trip hazard. So anything that you want to remove, put it in that yellow area of the pages. Something else, since I see a few water bottles, it's completely fine to have them. Just make sure that they are closed tightly. And we are not going to allow you to have anything that is open, like just a glass or coffee without a lid. So things like that, we're going to say waste or outside or outside or something like that. That we want to prevent any spills that there's a lot of equipment, there's a lot of electric outlets around, and those can cause issues. Cool.
Certainly no food.
And yeah, no food. Definitely no one. Good. Right. Something else that can happen is phones. Like if someone is typing, that's completely fine. In this area, it's completely fine to do. So you can use your cell phone in here, not a problem. But we have the high-tech area in the back, and when you go into that area, please avoid using your phone at all times. It's actually not allowed for you to use it. The reason is that because we have specific machines that are primed especially to fire, the laser cutters is the main one. Fire can grow really quickly in a matter of seconds. So we need you to be completely aware of the surroundings. And if anything happens, you have to let us know and react as soon as possible. We're going to give you some instructions as well about the safety buttons and what to do if there's an emergency. To start with, we have in here those yellow and red buttons. That's going to be the electricity shutdown. And you can press it at any time if you see that there's any issue. Now that we're going to go into the laser cutters demo, it's going to be really important, especially with this coming hard, that I might be talking with some of you, there's a lot of people, so pay attention to the machine at all times. When we go into the high-tech area, we're going to ask you to help us paying attention to the machines. That things can go wrong quite quickly. Not that it's something that happens often, but when it happens really quickly. So please help us to make sure that everyone is safe. Sounds good? Beautiful.
We'll just add with the personal protective stuff, there's other protective equipment down here, which is your headphones and gloves, depending on the job that you're doing. Often in the high-tech area, you might need the ear protection because there's equipment there that's quite loud. It does depend on what's going on in there. So.
Yes, for today, because we know we're going to look at the laser cutting, and we're not going to use any of the other machines. I'm not going to ask you to have them demo on. But as well, if you come any other day and you want to go, or you are going to go into the high-tech area, we're going to ask you to keep it with you. You don't have to put them on immediately. It depends if we're using some of the machines. But if we use them, we want you to be ready to put them on. Right. So every time that you go into the high-tech area, remember to grab some of those.
Just the headphones, not the gloves.
Yeah, the earmuff.
Yeah.
Cool. Safety glasses still everywhere. As soon as you pass this table, remember safety glasses. Sounds good? Beautiful. I think that's the most important things at the moment. I want you to actually help me out. I want to understand a bit more about
Should we just
what
do
everybody's doing.
Evacuation.
Yep.
Yeah. Just in case of an emergency, I just want you guys to know that we can exit through this door. There's the green button and the emergency green box underneath it, which keeps the door open. And so you exit through there and move along there. Alternatively, you can move through this front door and out to there. Okay? So you assemble generally across the road or in that area, just down kind of that way. Okay? Cool.
Yeah, in case of emergency, you have those buttons. Again, electricity is going to be the yellow and red, and for the emergency exit, green and white. You just have to open the lid and press it, and it's going to keep all of those options. And anyone can press it, so feel comfortable to do it if it is an emergency. Cool. Right. Next up, I was going to ask, what is it that you're trying to do for me to be more specific?
I think just to introduce us to what sort of machines would better help us better showcase our design. Like some of us have very organic kind of shapes, so I think 3D printing would be good. Some of them need like etching, so laser cutter, like all these like etchings as well. So all these, how do we prevent it like from getting burned or what come to?
Okay,
So
good.
those kind of design, like which machine would be better suited for?
Perfect, that's good.
Yeah.
All right, and I want to ask you guys, do you guys have questions? Girls, actually. Have any questions, no specific questions about the space, the machines? What do you know? What do you want to know? And that way I can also help you out. Anytime,
I got a question. Yes. My design is one of those organic ones that would probably best suit 3D printing. And I know that we're not covering that necessarily today, but if I was to come in at a different point, I would bring what sort of format, like a SketchUp file of it? What format do you need that in to convert to the printer?
I would recommend you all for all of the types of processes that we do. If you're not sure what the process is or what you have to do, or if the model is ready or the file is ready, you can also bring your laptop, bring the files in the original format. SketchUp is okay, we can have a look.
Yep.
If you feel that it's ready to print, for 3D printing and CNC milling is going to be STL, stereographic file format. STL.
STL. Can SketchUp transfer to STL?
Yes, you can export.
But it's really good to, if you come in and bring your laptop in and show us what you're working on.
Yeah.
And because often with SketchUp in particular, there can be issues with converting. And it's just some troubleshooting.
Right.
We can do that, help you do that, or recommend other ways of doing it. So we can just kind of work through and get it ready and show you that process.
I would imagine that you'd want to bring just the part that you're wanting to print, right?
Yeah, I
Like-
mean, it's on the laptop, so you can bring
Yeah,
all
but
it
you
just-
can like delete the
Yeah,
other
you
parts
can
that
delete the
like
other
is just the
Yes.
background.
Yeah.
So be pure with what you're bringing,
Yeah,
what
just-
you want
yeah.
to print. Yeah. And then is there someone here at all times, or is there certain times that you guys are open, and does one need to make a booking?
Yes.
No need for the booking.
Yep.
And Amy and myself, we are full time in here, so we are every day
Yep.
here from 8 a.m. to 4. And we have a small break, 10:30, is 30 minutes to grab coffee, is to refresh. And 1 to 2 is lunchtime.
Right.
But between 8 and 4, on
Yep.
your time, you can come here and we can help you out.
And I'm here Monday, Thursday, and Friday
Yep.
from 8:30 till 6.
Oh wow.
So Monday, Thursday, and Friday, you can come extra time between 4 and 6.
And this is what you guys do. This is your domain,
Yep.
and the school pays for you guys to help us out.
That's why we're here. So if you, you can just come in here and show us what you're doing, and we'll help you work out how to build it.
That's
our
so
job.
cool.
Yes.
And so in terms of payment for the materials, we bring our student card and there's some sort of a payment structure, or is that part of the provide?
Essentially, if you're doing a 3D print, we'll analyze it in the software, and that will give us a cost. And then it's just as simple as us invoicing you through your student number, and then you'll pay that online. It has the links to do that.
We'll figure out roughly what it would be before we go ahead with it, right? Like ballpark it.
It gives you an exact amount.
Oh, right. Nice.
And then
This is good for everybody. So 3D printing, we only charge you by weight. So that's why we have to wait for the software to tell us how much it's going to weight, because it depends on the resolution, the size of the model, how solid it is. It could be that it's a structure that takes a lot of space, but it's quite empty. So that's going to be quite light. Or it's something that is quite solid. So it's going to have a lot more material, more weight. That's the way that we charge in the 3D printing.
So for instance, these objects here are hollow, and they're quite large, so you might expect that to be quite expensive, thinking that's maybe about a $20 or $30 print, whereas this one is quite solid and probably would cost the same or perhaps more. And when I'm talking about hollow, so this actually has a structure inside, so it's not completely solid, but it's got like a lattice or a grid, and that's kind of distinguishing the cost there. So time is not, you're not paying for time. So high resolution prints are not going to cost you more than low resolution. It's really just the material, and we're super cheap compared to anywhere else. You'd be paying probably, well, the guy came in a while back and I think it was about $12 an hour you might be paying for 3D printing. So you're not paying, and so for instance, this is like a 16-hour print. You're not
Wow.
paying that at all. You're just paying for just the material.
That's amazing. I can't believe that it's last semester, second year that we get introduced to this after all the model making that we had to do so far. But it's great. Thank you.
Now for laser cutting, you also only pay for the materials, so it's going to be a matter of defining how much material you need. We have different sizes. For reference, in the 3D printing, you print a size of roughly 180 by 200 and 190 of height. So that's the volume, roughly the volume that you can print as an average. For the laser cutting, it depends on the machine that we have in here, which unfortunately we only have the small ones working. Hopefully soon we're going to have the big one working as well. but the size now is going to be limited by 400 for 300. And whatever you can fit within that material, then you have to get more pieces of that size and put all of the pieces that you need for your model to fit within all of those. Each one of those is going to be, I think, we have all in the system, so we just put the numbers. This is roughly, I think it is $2 for that 400 by 300. We also have the big one to be 1200 by 600, which we hope next year to be functioning completely by next semester, so you can use it. And if you want to do it for this semester, which is just a few more weeks, you can go to 202 workshop. Has anyone been in the 202 workshop?
No.
A few of you? Cool.
Huey.
Cool.
Of course.
So you can go in there. There's another laser cutter, big format. That one is 900 by 600, and again, is depending on how much you can fit within that size, and then how many you need.
And of course, you guys have these materials here, so we can
Yeah.
look at it and pre-plan accordingly on what we want to make it out of.
Yeah, so generally,
Yep.
we prefer you to use materials that we supply.
Yes.
That's not to say that you can't use materials you bring in, but you need to bring in a material safety data sheet about that material, and also I should say no second-hand materials. So you can't use wood you found off the side of the road. We need to know, if there's glue in the laminating process of that wood, what type of glue it is, and so we need that information. So the safest bet is use what we have, or come talk to us, and let's find the material safety data sheet, and we can go from there.
Okay. And you will show us what these materials are in our little induction today?
Yes.
Wonderful.
Didn't really talk about milling.
Yeah.
Han, we need to, obviously, you said that this print took 16 hours. Obviously, one wouldn't come in last minute on their assignment going, I need this printed for a due date tomorrow. What would you say is a good planning for printing from an assignment due
Come
perspective?
in as early as possible, minimum of a week
Before, yeah.
Like,
In case things go wrong and you got to reprint.
Sort of jump in. Like, I think really what you want to do is make printing part of your design process. If you think you're designing to print frequently and often as you design, sort of like maybe you're thinking about the general form of it, print that. And then you're thinking about a certain feature of it, print that as you go, as you kind of build your way up to producing a final model, rather than treating it as something you only do with a finished project.
Yep.
Do it throughout that process.
Good tip,
as much
yeah.
as
great
can.
advice. Essentially, like you can print some various prototypes of the finished idea, prototypes of what the complete idea might be, and then also maybe it might be just joinery within it or something
Yep.
like that.
Yeah.
And you might want to tweak the design as well.
Yeah, so let that inform your design process, because as you test those things, you'll discover things that maybe you can't do, and you'll discover things that you didn't know were possible that you can build into your actual design,
That's awesome.
The more you come in as well, and the more familiar we become with you guys, eventually you'll get to the point where there's self-serve 3D printers in the high-tech space, and you'll be able to load and manage your own printing. So,
Yep.
You can just tell us how much
Yeah,
material you've
you
used,
just-
and you can go ahead and do it yourself.
and it's good for us because we just go, cool, go do your thing,
Yeah.
and we can help other people. So,
Oh,
yeah.
this is awesome.
We have quite an array of colors, but only one material, which is PLA. It's a non-toxic material. I should warn you that it has a low melting temperature. So I think is it 50 or 60 degrees?
60 it starts to
60,
soften,
so-
but it won't melt up until it's about
so
100.
about 60 degrees Celsius, your parts might warp. and
Don't leave
bend.
it in the windshield
so
of the
you
car.
don't want to leave it on a window in a car or something like that. It's non-toxic. At some stage we might expand our material diversity, but we're waiting for air filtration. We do have quite a few colors, reds, blues, yellows, etc. Silver, transparent, and this wood filament, or pseudo wood.
It's brown.
Brown. It's textured differently as
Yeah.
well. Yeah, and then also we've got the milling machine, which we haven't mentioned. So
That's real wood.
some people are passing around wood pieces, and so that's when we go to the high-tech space, you'll see the CNC milling machine, which is a subtractive technology as opposed to additive, and that's how those pieces are produced.
And with a computer, it cuts away at it.
Yes.
Yeah, it's like a
Wow.
big drill that moves. Yeah.
That's amazing. I'll be toiling away with a knife at home. Not doing that again.
Yeah.
This is great. Yep.
All right, I would say we can move to the high-tech area. So remember, while you move to that area, grab the safety glasses, some wipes if you want to clean them, and we can have a bit of a look to the machine.
Wow, look at the detail.
Anyway, so I'll just keep moving on. Another feature that we have here. No, I'm starting. Alright. We have this laser scanner. Wait. Alright, so if we don't almost. You can come right in, don't get scared. The door actually closes randomly, so I suggest coming all the way in. So we can also scan objects as opposed to just printing them. This is high resolution laser scanner. While using it, you need to use these particular safety glasses. It is a class 1 laser, and so it is very dangerous to your eyes. You cannot look at it. It's also important when you are using it to not point it at people. There is a range of about 1 meter, where it's after about 1 meter, it's not dangerous. But having said that, we always go for safety. So while you're using it, you wear the glasses. You don't point it directly at people. If you did to need to scan a person, they can wear the glasses. That's fine. Otherwise, other people should be kind of trying to stand behind the person using the scanner. You should advise that you hold it at face while using it. This scanner in particular is better suited for objects around the size of about 30 centimeters or 20 centimeters in height. So not super small objects, not shiny objects or transparent objects. There are ways of getting around that. You could just kind of dust some flour or something on your object to take the sheen or transparency away. It's very easy to use. You just kind of point, shoot, move around your object, and it creates a beautiful 3D model with textures of anything. So I don't know if you wanted to do a chair, you could do that. If you wanted to do desk, anything, you could do part of a building as well. And then you can bring that into whatever software you're using as an object, and or 3D print it or remix it, however you choose. So yeah. So that's scanning. Other equipment we have, which we mentioned, is tucked away in this corner, is the Cnc Milling Machine. So actually, before I do that, I probably should have said the safety stuff. Very important. This is the emergency stop button. This will stop the power to this room. So if there is someone being unsafe or a fire or anything like that, please press that. And again, this is the exit green button and emergency exit here as well, which will keep the door open. Jumping back into the CNC, probably hard for everyone to see, but essentially that is it's like a drill, but it's on an X, Y, and Z axis. So left, right, and then up and down. It also has a rotary axis. So we can put a chunk of wood in there and then rotate that. Essentially you can do top, bottom, left and right in terms of the rotation. It also got the big red emergency stop button on there. that is quite a labor-intensive machine to use because while using it, we require you to make sure we'll kind of clean it out every. Really depends on the design, but on average it's about every half an hour. So if I just jump through here, sorry. Essentially you'll be lifting this up, using this vacuum cleaner and getting out the bulk of the wood dust. The reason is essentially you're spinning this drill bit very fast and you're making all this kind of sawdust and little pockets. And so it's a bit like rubbing two sticks together. It's really easy to create a fire.
Right.
But we can get some really beautiful stuff out of this, and Amy in particular has been getting really up to speed with using new software, so kind of pushing what the machine can do. But so on, so I think this one took 9 hours.
Whoa.
But relative to printing, it's not too bad. Also, it's solid, it's wood, it's strong. So for instance, if you had a project that was going to take 9 hours to do, because with printing you can put it on, you wait around for about 5 minutes and then you can go and come back and check in. But with this, we would need you to kind of come, sit, wait around as much as you can. If you do need to go to class, that's fine, go off to class. We'll try to watch the machine, but often we'll get busy, so we might have to pause the machine. So an 8-hour job might end up running for 16 hours because it's paused. But I mean, you get to build things out of, wood. We can also put plastics in there. We haven't done it yet, but it's feasible.
So if somebody else is also booked in for this, then there's a bit of a toy between who gets the first come first serve type rule, or
Yeah, it's not. So but it's not really a booking. It's whoever shows up.
shows up. Okay,
Yeah.
just be here.
Just be here.
There's not many people here now. I'm surprised, and
No.
it's assignment times. And
Yeah, we're quiet. So.
wow, okay, you'll be seeing me.
All right, that's the basics of that. We'll move you further down. There's a fair bit of prep in terms of setting up your model for that, but we'll help you and guide you through that. That is a machine that we kind of set up, but
Yep.
you just, once we've set up, you vacuum clean and kind of supervise or in that sense. But we're kind of-
Assistant.
yeah.
Okay. Awesome.
Camillo's still busy there, so this is the laser cutter. It's not current. Well, technically it's working. We just don't have any fire extinguishers, so we're not allowed to use it.
Was Bunnings sold out?
We have to get them for a certain person.
Right.
So this is probably the most impressive bit of kit we have here. I think it's worth about 150 grand. It's infinitely faster than the laser cutters that you'll be using here. A job on the Emblazer laser cutter, if a job on that laser cutter took half an hour, on this laser cutter it might take 6 minutes. So
Wow.
much faster. Also, the quality of the laser cutting is higher, and the thickness of the material you can do is thicker.
You can make bigger pieces on
Much
that.
bigger
Mm.
build plate, and in time we will additionally put extra extraction on that, and so we should be able to cut things like acrylic up here as well.
Wow.
But at the minute, we are limited to strawboard. So these are the materials that we have, so if people want to have a sense of it, and then this ply. But we do have some different thicknesses. So that's
3 mil, 6 mil.
6 mil, and
Yep.
then what do we have in
1 mil and
strawboard?
2 mil.
There you go. Perfect.
Well, that's good to know when you have to stick it all together, is knowing, okay, well, what, scale do you need it, where your wall thicknesses are, to get a bit more realistic on
It's
the...
actually one of the most important ones that it seems you might have to use it is putting things together, and it's called an assemble type of job that you do normally with 2D pieces, and then you make it 3D. If I can put this apart. Broken.
Uh-oh.
And we need to cut more. So you see that this is all 2D pieces.
Yes.
But when you put it together, you can sag it in those 3D pieces. But the important thing is that then you have to consider the size and thickness of the material to make everything fit. Like for example, in this one, this is not the right size, it's not gonna go inside, or it's gonna be too loose and everything is just gonna fall.
Oh, so you might need to consider designing for Legoing it together later.
Yes.
So you
Right.
need to get the tolerance in there, and
Exactly.
you know, although we said it's a 1 mil bit of straw board or a 2 mil bit of ply, I always recommend coming in and just doing a quick measure,
Yeah.
some calipers, because I believe this is actually 1.2, not 1. But that will depend on the batch. So always good to just double check that and then have an offset tolerance. Depending on your project, I don't know, 0.25 I find is good, but again, that depends on the material. That's a good one for 3D printing, but it depends if you want a really snug fit or a loose fit. So, yeah.
For any type of work that you do with 3D printing, milling, or laser cutting, it's always good to do a test, especially if you're going to assemble pieces, because things can change quite quickly. That they might be really hot in the summer, so the pieces, especially with plastic, might expand a bit more than usual, and it's going to be hard to determine how much is that expansion. So it's just not only the only way to find out is to actually do it, put it together. And it doesn't have to be the full piece that you're trying to create. It could be small, really tiny pieces that you do is to that assemble together, and then it lets you know, all right, this is not really the right size. Let's make it a little bit bigger and make it work. So it's always good. Do test. Always do some tests. You made the question about how long or how much time you would have to prepare yourself or give yourself to do things in here. As Josh mentioned, it's good to give it at least 1 week, especially because you have to test a lot of times.
Yeah.
It's not only about having the model done and then come in here and print, because that on its own takes time. Like 3D printing takes about an average of 1 to 2 days just to print. But before that, you have to do tests, and you also have to make sure that the model is correct. A lot of times it takes a couple of hours to fix any issues with the model. We can help you with that, so we're more than happy to give you guidance and tips and tricks of what to do. But it takes time.
Yeah.
So it might be that you thought, oh, this is ready to go. You come here, we have to fix a few things, and you don't get to print until the next day.
Yeah.
I would add that it's quite a low key, and we're not very busy today, but other times we'll have 20 students waiting to print, and it just won't be a case that we'll be able to help you with your model, because if you get here at 8 o'clock in the morning, we will.
Yeah.
But other than that, we've got to get the volume through. So I always suggest if you need help, get here early in the morning, because it's quiet. But in those towards assessment time, we can get exceptionally busy. So that week that we're talking about prepping, include the idea that we might not be available as well.
One last thing about that preparation of the material that you want to do, the model object, is don't wait until you finish or when you think that it's done, because it makes it really hard to help you fix things, because sometimes you have to delete and redo things. So no need to do everything at the end. You can come through the process, and it's even good to do those tests when you're doing the process, because if you do the test at the end again and you realize the tolerance is not good, you would have to redo the model a lot of times.
Yeah, the last thing you want to do is build all these things that slot together, spend 9 hours cutting it, and then realize that it's all too loose. Want to cut one, check it, maybe cut 3 different variations with 3 different tolerances to say, oh, that's to find the right balance, and then go and do the next bit.
Yeah, don't wait until the end. You can come here with some of it, and we can help you out and say, okay, that's good for a test. Let's do a test, see how it goes. We can tell you as well, this might not work quite well, so everything that you have to do after this, do it this way. Things like that. So keep that in mind. Cool.
While we put it up, do you want to show us?
I'll show it.
Show later? Okay.
Yep. And we don't have that much time. Which reminds me of saying this. We do have to give you an induction, a full induction of the space. So this doesn't count as an induction.
Oh, okay.
And you have to do the induction to be able to work freely in this space. So we do the inductions in the first few weeks of the semester, so we don't do any more for this semester. So next semester, remember to do those inductions.
So it means we can't use this.
We're going to lead you specifically in specific machines. So
Okay.
you have to be, if you want to do 3D printing, we have to take the time to go through all of the induction for the 3D printing.
Right.
So it's going to take longer. And the main issue is going to be if it gets busy,
Yep.
we don't have the time to give you that induction, so you won't be able to use the equipment.
Got it.
So that's going to be important. If you want to do something with any of these machines, I would recommend you to come early so we can give you that induction. There's not going to be people beginning of the day, so we can do that. And then after that, you don't have to worry about it.
So 8 a.m. Monday is the best time? Right.
I'd
Okay.
say so. Because yeah, we have to give you the full induction for safety
Yeah.
purposes.
Are you guys actually architects or working on a different project outside of uni here, or is this solely what you do is assisting the students to do 3D modeling and printing?
I have 2 other jobs.
Oh, right.
Mainly doing large scale public art or lighting,
Right.
but also kind of concrete and various other things. Background in engineering and contemporary art. Camillo has worked in architecture.
Yeah.
Because he's full time here.
Yes. Okay, now that makes sense then. So it's good to be on top of the technology of this as well as you doing other things as well. So
Yeah.
it does make sense for you to be here to serve us.
We both have like pretty good background in software,
Yeah.
which is really handy because the software part of digital fabrication is often forgotten. So you know, we need to get the models ready, and that's
Yeah.
it's a bit of a learning curve.
Seems like the biggest part is the software and then the output, the machines. That's awesome.
But I understand Camillo. He's also, worked in it. Had his own firm for a while and various work for other people.
I am an architect. I'm accredited as an architect. I'm from Colombia, and I'm an official architect there. I design a few urban design park houses. I design and help remodel a few houses in here in Perth as well. I work in my own business in architecture visualization. I worked in the past in different laboratories for digital fabrication as well. Lots of experience. I gave classes in here for architecture as well, and method classes on software and production design.
Oh, wow.
More things.
So would this workshop ever put out a commercial buildings model? Because those things can cost up to $100,000 to produce a full size, high skyscraper type model. Like I know there's a model shop down in, is it Wembley or Jollymont? There's a little model shop down there and they charge, tens of thousands of dollars to create a model. Is that something that this shop could
This is
produce?
completely dedicated
Just for
students and
uni.
academic purposes. So we're
What
gonna
a
do some
secret
research.
gem.
We do have a guy, for instance, designing mini artificial reefs for fish
Yep.
ponds.
But
Oh,
it
yeah.
still does research.
But it's research, and
Right.
he's affiliated with university.
So, our main purpose is the students, help the students to try more things and explore more things.
Yeah.
So that's the main purpose of this. We might do some prototypes and large scale. That's one of the plans that we have in our heads that we can use over the courtyard. So it will be really interesting for different backgrounds, undergrads in here, architecture, for the purpose of an actual prototype, interior architecture to explore the inside. Fabrics, with 3D printing, it can become kind of like a lab of what we can do, but that might take some time because we want first to establish everything to work with what we already have and the courses that we already have and the classes that we have and the content that they have.
I mean, we've only really been up and running for
One semester. This is the second semester.
Yeah.
Oh, right, yeah, a new
Like,
building.
We're
Yeah.
all pretty. I'm particularly new, but we're all pretty new here. So
Right.
part of our job has been getting things running and working.
Right,
And
yeah.
So, for instance, there's a Waterjet cutting machine in a box out in the main space there, which will be put in here. And so that will mean you'll be able to cut materials like marble and also metals here.
Ah.
So, but it's just been like we're just trying to get
Yeah.
everything ready, and there's a fair bit of infrastructure that has to happen to get that done. So
Yeah.
as time progresses, we'll have more machines and more facilities. So.
All right, because we're running out of time,
Yeah.
I'm gonna go really quickly into the laser cutting.
Right.
One last thing that I want to mention is there's some cards passing around, and things that you need to remember. For laser cutting, you need to give us a PDF file. For 3D printing and for the CNC Milling Machine, it's an STL, so you have to do the 3D model. But for laser cutting, it's going to be 2D objects. So you have to do any vector-based, or you have to use any vector-based program, Illustrator, AutoCAD, Rhino, things like that. You can use it. It's the main thing, 2D drawings. You're going to need to give us lines. That's the main purpose of why it has to be vector-based program. And those lines have to be color-coded. So if you want to do cuts, you need to do red. You need to use red lines.
Red for cut.
Vector engrave is going to be green, and for fill it's going to be blue.
So that's
Right.
pure red.
Yeah, also to mention RGB colors.
Right.
So when you go into the settings, I can show you really quick in Illustrator. Always remember you have RGB, so the R make it 255 and the other two 0. If you want to do green, that green is going to be 255 and the other two 0, and the same for blue 255 and the other two 0. You can do the same for AutoCAD and any software is going to let you set up those. But remember RGB colors. That's going to be the main thing.
Okay.
And the thickness. Hairline.
Yeah. Slowly, we're getting there. There's a few things. So, just to be clear about engrave, vector engrave is going to be just a superficial cut that is in here, and you have the fill that is basically everything inside. Something that can be confusing is that you will try to do the solid in the software or hatch something inside to do these kind of things. You don't need to do that. You only need to give us the line, and the software is going to recognize that it's blue, and everything that is inside that blue is going to be hatched in this way.
Also, it does the hatching for us.
Yes.
Okay, cool.
So if you want to do, for example, that is the rectangle and you have a hatch that is just lines, a reticular line, then it's going to be a vector engrave line. So
Okay, so if we
not
want to make
fill.
like an outside shingle look or something, we would draw it in the middle one, which is the green
the
color.
vector engrave.
Yep.
Because if you make it blue, then all of those rectangles are going to be filled with this type of fill of hatch. Then it takes you into the thickness, that because we need them to be the proper line. If you give it any thickness, especially in Illustrator, you can change the stroke. That might recognize it as a fill instead of a line. So any line, instead of doing the actual line, is going to make the entire fill of that line. So it's going to be important that you make it always thin, hairline thin. That AutoCAD or CAD software are going to have that reference of hairline. Some software, Illustrator is the case of having the stroke size, is going to be the recommended 0.01.
Oh.
Makes sense? That's the thinnest that it can go, and you select everything in the page, and then you change the stroke into 0.01, and then you export it to a PDF.
So when you cut onto, that's an MDF timber thing, like that's wood that you're holding there. Obviously, it's going to burn and like it'll burn
Yes.
away. So it's not going to be 0.01 in real life printed
No,
or burnt
it's
away.
always the same thickness. That's the thing. Doesn't matter what it is. All of the lines are going to be the same thickness, unless you give it that hatch.
Yeah, but we should think about it that it burns away from the line. So it will change the size. If we want something to be a precise size and we cut it, it might cut away from it.
The thickness of the laser is so minuscule, you won't see that.
It'd be pretty precise. Okay,
Yeah.
just
So you
assume
don't
it's
have to worry
precise.
about
Okay.
that.
The one big error that we get is miscellaneous lines underneath other lines, and so that's gonna. So what I mean is, like, you might have a line and you might have another line just sitting directly underneath it, and you don't know it's there.
Yeah.
And so that actually gets the laser cutter to cut that line
Twice.
and that's can often mess up your work, or that's a kind of a fire type thing as well. It's not the end of the world, but that we don't want that generally.
Yeah.
I'll also add that there's a pretty comprehensive document, I believe, on Blackboard, and it's through digital modeling, I think is what it's called. Is that right?
Yep.
And that has all this information about the line weights, colors, and has the information about the materials and the sizes of the materials on it. So I highly recommend just downloading that PDF and having a read, just to refresh what we've gone over today.
Would we be able to get a copy of that PDF sent to us? Thanks, Yumi.
All right. Let's see if I'm missing anything. Yep. This is the last one. You see this gradient here. That is actually not possible to do with just lines. You don't get to do any gradients. It's always going to be the same tone for all of the lines. But this type of gradients, you can do it with images. So if you place an image sample, so we only have one sample.
What's that little dog
that
thing?
brain.
Yeah.
So it is an actual image, and we can pass it around as well.
It's on straw board.
Has gradients. It's going to be basically a black and white image, and the only way to get it to do it in the laser is going to be place an image. So it has to be a JPEG or PNG image that you place in the PDF. Make sense?
And it will convert it to black and white, or we should do it in black and white?
No,
Or-
it doesn't matter. It's
That
gonna
it
take
would
the
just-
color tones.
Okay.
Cool. We're missing something now. Cool. We're supposed to have the next group at 12, so we don't really have much time for them. But if you come here, I can show you really quick how it works. So, for example, in Illustrator, I was going to show you, one thing that you have to do is make the artwork the same size of the laser cutting. So that lets you know if you are within the material. Because if you have things outside, well, it's not going to work. So keep that in mind. And something that we recommend you as well is to do rectangle outside
What program are you in here just now?
Illustrator.
Illustrator, yep.
So if we do, why is it not letting me? Yeah. Cool. So recommendation is make a rectangle that goes from corner to corner. Make sure that is use the stroke, so no fill. And that's simply to align things. So when we go into the software that we use for the cutting, we know where the page is. It's going to help us make sure that everything fits correctly in the material. So that's been extra. In AutoCAD, or what other software do you use, really quick? AutoCAD? Yes? Any other software? Or
I use
drawing?
SketchUp.
SketchUp for 3D modeling. Anything else? Those are the main
Yeah,
ones.
Photoshop, Illustrator, all the Adobe products, yep.
So in AutoCAD, it's going to be simply do a rectangle outside. Again, it's good to know that you're within the material, so always do that. And doesn't matter what color it is, we're going to delete it after. It's just for us for reference to make sure that everything fits. Especially if you have shapes that are not rectangular, it's going to be hard to make sure that everything fits correctly.
Right.
So it's good to do it all the time.
Just remind me again the size that you can print here.
So for this one, it's going to be 400 by 300.
400 by 300. So make the rectangle 400 by 300.
Yes. It's
Okay.
going to be the artwork to be that size. Cool. And then it lets you also know that you're within that material, so you know how much material you need, because we're going to charge you by piece of material.
Right.
Cool. Right. After that, use isolation to make sure that you select everything. I do Control A, and in the stroke, just go here, 0.01. 0.01. Good.
So the example you've got up on the screen, it's really Tetrising in as many pieces of the puzzle on one page as possible for economy reasons.
Yes. So that's another thing. It comes to you because you're the one paying for the material, but we recommend you to fit as many pieces as you can in the minimum amount of space. That's going to let you do more things in one piece instead of spreading everything into the pieces, and then you have to pay for multiple of those 400 by 300. So it's good to fit as many as you can. So to keep in mind, give at least 3 mil of space between the pieces. So don't put it all perfectly together, because then it's going to match the lines and it's not going to work correctly. If it is too close, it might burn the next one.
Right.
So 3 mil is a good space between the pieces. And 5 mil from the outline outside. So give
Yep.
always that margin of 5 mil.
Right.
Good. Cool. So you're gonna see when you change it to 0.01, everything becomes quite thin, but that's correct. So don't be scared that looks strange, because as you can see in here, those blue lines might export actually as an outline instead of one line. Yes?
Is there a way to minimize the burn, or can we erase the burn? Last time I think someone told me can use 11.
Do you mean this type of burn?
It's sandpaper,
Sandpaper.
really high.
So something that is going to happen is the front is quite clean, but the back gets quite burned. So you can plan ahead and think if maybe something that I do often is, because a lot of times you have to put two together. So you make it a mirror, and then when you stick it together, you have the both clean size correctly. If you have to keep that one, sandpaper in plywood works quite well. Something that I do actually first is use an eraser. Try to do, sometimes it removes some of that. Something to be careful about is the straw board. If you try to sand that one, it doesn't look too good. So it's going to be quite hairy and it looks strange. So first with the eraser, try to remove it. It comes out quite well with an eraser in the straw board. The wood is a bit harder because it is actually, the sap of the wood gets sticky and it's not going to remove. So sandpaper is going to be the best way to go. Something else that I recommend sometimes is for models is painting. You can paint the models spray painting, especially I like how it looks. You give it a good grain when you paint a straw board. So it looks quite nice, and painting looks quite good as well. So multiple things that you can do with those. Good. Right. I don't know if the next group is coming soon.
This was the majority of the class, wasn't it?
Yeah.
Yeah, we had a small class today.
Good. We'll keep an eye on it. Kevin said that someone, so a different group would come.
Yeah.
All right. Let's try to do this. All right. I want to ask, with the things that I've said so far, that we've talked so far, do you have any specific questions or anything that you wonder? Try to imagine what you're going to do with your own model and think what works better. If it is going to be laser cutting more efficient, if you have pieces that might need assemble, or maybe 3D printing is going to be better, or maybe you want wood to be the material that really represents your project, and then milling machine is going to be the best option. So start thinking about that. And questions, what do you think?
Would wood be cheaper if your thing is a bit solid? Like, you know how you said that the plastic was on weight?
Mm-hmm.
Would the reductive method of producing a shape be more cost efficient? Or bring it in
That's
and we'll find out.
something good. And because we're using wood and we have a wood workshop in 202, a lot of the pieces you can get scraps, and because everything is going to get cut, it doesn't actually matter if it is perfect on the outside. So you can grab any of the scraps from 202 for free, so you don't have to pay anything for those.
Oh, wow.
If you want a piece that you couldn't find the piece in there, so you would have to buy the wood outside. We don't have any wood to sell or to give you for you to pay. We are counting to use a lot of the scraps that you can find on 202, which is a lot. It's actually a lot that you can find in that.
Okay.
So it would be free for that one.
Great.
When it comes in that way.
Thank you.
Good. Any other questions? Everybody around there? Anything comes to mind, or anything that you wonder about laser cutting? No? So far so good? Excellent. All right. Let's see. Let's do a quick sample.
This one's wasting a lot of
what is
material.
Yeah, I'm not going to cut everything.
Okay.
Just trying to think, how many things can we do? I wanted to do one of the little rockets, but I couldn't find the file. So that I had it in a folder. And then if you do landscapes, and what do you usually do? I'm trying to think what is more appropriate for me to show you. What is the most usual thing that you would do?
See, we're interior architecture students, so eventually this sort of technology would be really helpful if we have to do models with interiors, with furniture and interior little bits and bobs.
Little pieces.
Possibly that, but for this particular project, I don't know, with people's bridges.
Like contour lines.
Yeah, that's a
Contour
good
lines.
one.
So landscape would be
Yeah.
good. And this one is more of an example of landscape, so I can show you that. That's good.
Okay.
Anything else? What else? What do you think? What do you think is the main thing around here? What do you lady think? No idea. Blank.
Yeah.
That's okay. No ideas. I'm gonna.
For specific rooms sometimes.
All right. In what way? Walls, maybe.
Last semester we did like walls with windows and all that different stuff, I guess.
All right. So an actual building. Cool. I can show that. Anything else? One
When
more
we
thing.
have to produce patterns on something, like that's part of the design. Somebody had a really nice snakeskin handrail, and maybe that would need to be very quite intricately done. Best to print that than try to draw it on manually. That could
Good.
speed it up.
Okay, that reminds me. This is something that I forget to show. All right, something else that you can do. This is really interesting. That you can do flexible things.
Yes.
So this is called curve laser cutting, Kerf, and it's simply by adding a pattern on the top. It lets you do flexible things. Let's do this one. Something like that. So we can help you as well to figure out how to do things like this that you can start thinking. It made me think of the rail that you mentioned.
Yeah.
Something that can become flexible. And it's simply, the way that it works is you remove some of the material so you have enough space to bend without breaking. So you can make it on one go flat, and then you can bend it to whatever you want in the shape.
This
That's
one
something
you'd
good.
have to test to see where the breaking point
Definitely
is.
lots of testing. We have some pre-made samples that let us have an idea where to go, but it depends on the scale, how big it is, how small. So that's an interesting one, curve. Laser
Also,
cutting.
also that you can laser print curves if you think outside the box. In this example is actually a curved product at the end of the day, but it's not 3D
No,
printed.
it's 2D.
Yeah.
Which is one big thing about laser cutting is think that you can do a lot of 3D things by assembling, by bending.
Yeah.
This is another project that I was part of. See if I can find it very quick. Yes. So this piece, whoops, that's not it. That is actually made of 2D pieces. So I was part of this project, and the way that it did it is you have each one of these, you can kind of see the rectangle in here. It was cut in a CNC bed. We have one in the 202 workshop. And then by bending the wood, it starts to grab that shape. So I think that you can also do bending and assemble of things that is going to make it 3D. That's the most interesting part of laser cutting. Don't only think of 2D walls and just assemble in that way. You intersect the pieces. Try to think what happens if you bend it. What happens if you add the curve type of material. So that's always good. Try to think of it beyond that. Because a lot of times it's a model that looks like it could be too complex to do in laser cutting, and you go directly into 3D printing, but it's actually not efficient, or it's not worth it to do it in 3D printing. It's going to be better to do it in this way. Yes?
Upstairs in our design. So how do you recommend to like build a stairs?
The stairs?
Like steps.
Yeah.
Is it laser cutting?
I would normally go laser cutting actually, because it's just 2D pieces that you put one on top of each other. It's quite efficient. You just have to cut rectangles and then stack them.
You would have to design like the fold line for you to glue it together to create that though. So, little tags to fold over
Yes.
to glue.
So something that, and I can show you here, for the landscape control lines, you have to do the same thing. If we take this one, so if that control line goes in there, it would be good to have a line that tells you where that goes. So we make in the CAD model this line, I will make it green, and then the piece, I know where exactly it should go.
So when you're gluing it together, you can
just
match it up.
Perfectly
Yeah.
stack it together. That sometimes, well, it's easy in this case, that is, you can align it with the outside, but some contour lines go right in the middle.
Yeah.
So you have no idea where that goes.
Yeah.
So it's a good idea to do the same. With the stairs, it would be, let's say these are actually stairs. So what you need to do then is, if the next one stacks here, then you would have to think that you cannot cut these rectangles, that is the outside part. You need to give it some space underneath so it can sit on top.
Mm-hmm.
So you actually cut that rectangle. And with the stairs, it's literally the same rectangle over and over and over. But you make a line with green right in the middle. So you keep stacking it. Like that. Make sense? I don't know if everybody can see correctly.
Can you create cut lines that you then create as a fold line? Can it be thin enough? So like,
To fold it.
you know, like if when it's a really
Actually don't test. Plywood? No.
no, not ply. Yep.
Mainly
Straw board.
because-
If you lightly scar a straw board, then you can maybe bend there
Yes,
perfectly.
And we've done some tests with that, and it actually works. But I would recommend you to go into, if you want to bend anything, to do more something like it is the curve. Because this time you might want a perfect 90 degrees angle. What you could do is simply make a dash line. Instead of making one green line that goes on top,
Yes.
you make a dash line, and that's going to remove some of the sections, and it's going to be less material that you have to bend.
Yeah.
And then we can do still the vector engrave on top, so you remove some of the material, so it bends quite nicely.
Obviously, foam board is not a material used because it would melt under the laser,
Yes.
right?
It cuts, but it produces fumes that we don't have the filters for.
Righto.
So any plastics produces a lot of toxic fumes,
Mm.
and it requires the special filters. We don't have them in here. For acrylic, we have the filters in 202, so you can go there.
Okay. Cool. Thanks.
All right. I was asking all those questions of what could be useful because we don't really have time to do the full demo for the laser cutting because it takes time. So it's something, the final thing for you to really remember about this laser cutters that we have in here. The tiny ones have less power. It's going to take a lot of time. Josh mentioned it. 30 minutes in here would be 5 in the big laser cutter. So sometimes it's going to be better to just go to the 202 workshop and cut things in there. We can help you with the files, make sure that everything is correct, so you don't go in there and find out that you still have to do things and then go back. So you can come here, we can help you out, make sure file is ready, and then you can go to 202, and it will be more efficient that way.
So as a step for all of us from here onwards, you did mention that we would have to have a formal induction for next time, but for our assignments to get it done in time, given that it's due in about 2 weeks' time, the best protocol would be to come in relatively early with wherever we're at in our design.
Yep.
And consult with one of you guys going, what method is best to move forward, what the type of print, type of output, and then go and tweak our designs and then come back and do it. So the sooner we can come back in, the better with wherever we're at work in progress, and then consult.
Actually, for the induction, you don't have to have the project. You can come without anything.
Yes.
We can give you the induction about the equipment because it's about safety and a few tips and tricks of what to keep in mind.
Yep.
But it's still, if you have something, doesn't matter how far away from, how far along during your projects, you just bring whatever you have.
Yep.
And we can help you out to understand better what you need to do, and even if you need to do something in 3D printing or laser cutting or milling, and you have to adjust a few things for each one of them. So it's going to be good to do it earlier than later.
It's a great free resource for us, even just the consulting with you guys to help us create something
Yes.
physical. It's fantastic.
So yeah, that's
Yep.
going to be important too.
Yep.
So, yeah. Everybody welcome to come Monday, 8 a.m.
Well, thank you very much
Not
for
a
your
problem.
time.
Yeah.